gain quite a bit. So going passive to active load, that's one way to increase your gain. Okay, now we had a whole bunch of slides. Another technique that you can use to increase your gain is cascoding. And I'm not making a mistake with cascading, cascoding. And that's where you stack two transistors. And these are just happen to be MOSFETs. But if you do this for a BJT, you get the same kind of effect. For MOSFETs, your R out increases by stacking these two transistors. They're not diode connected. They can't be diode connected. So once you diode connect a transistor, its resistance becomes 1 over GM. Looking into the collector, base, or emitter, it's all 1 over GM. So can't diode connect these because that just really kills the R. What you want to do is you want to show a collector to your output and then stack that on top without diode connecting this to another transistor. You're also connecting to a collector. And when this is an amplifier, the bottom transistor is VN. The bottom transistor is VN, and every time people make mistakes about this. If you have your VN over here, now you have a follower. Okay, and that's not what we want, or degeneration. What you always want with cascoding is the input to go to the bottom transistor. Okay, and when you do that, what you get is you get an R. If you're looking down, so if you're looking down into the collector of M4, what you get is a resistance of GM, where's your GM1? Times, that's right, GM4, GM3. Okay, so that this equation right here is for the left side. So when you look down here, the resistance you see is actually GM3 times RO3 times RO1. So you have an RO times an RO. You have 10 to the 5th times 10 to the 5th. Now you have 10 to the 10th right there times GM. And GM can be 0.1, it can be 0.01, it can be 0.001. It's still the resistance right here. It's going to be much bigger than just a single RO. Okay. Remember with the differential pair, when you look down, you saw a single RO. But now when you look down into here, you see a resistance on the order of RO squared. It's got this GM in front of it, and the GM is from the second transistor, not from the input transistor. So here's your, so gain is GM times RO. This GM is of the input transistor. This is your resistance. You see this GM3, RO3, RO1 looking down, and you see a GM5, RO5, RO7 looking up. And again, when you do small signal analysis, any DC source, that's going to become an AC ground. So that there will be two paths to ground. Again, this node's not going to move if you give it a balanced input, even though it's cascoded. This node isn't going to move, so you can forget about the other side and just treat this as basically a cascoded common emitter, which gives you the GM of M1 times the resistance looking down in parallel with the resistance looking up. Okay, so cascoding is a very good and often quite simple way to drastically increase your gain. The cost is now you have 5 transistors stacked up here. To go from ground to VDD, you have 5 transistors stacked up there. Each one of them is going to take a little chunk of the voltage. And so you have a couple of things that happen here. Either your V out won't be able to swing very far, or you have to raise VDD to get V out to swing as far as you need. So either way, there's some cost to using cascoding. You get a big gain increase because you've increased RO by a factor of RO. You've increased R out by a factor of R out, but in the process, you've taken more of your supply budget, your voltage supply budget. Okay, so there's cascoding. This particular, you can use cascoding in in a non-differential circuit, so this is a single-ended input, single-ended output. You can use it in a non-differential amplifier, or you can use it in a differential amplifier. So you can use it non-differential or differential. If you use it in a differential amplifier, you have all the advantages that you did with the differential pair. Strong against noise. You don't really have to worry about your biasing point. Get the same gain if you have a balanced input. You just have that overhead of using up a little more voltage per transistor, so your V out swing can't be as much. Okay, so that's one simple way to increase your gain. This is the analysis for a MOSFET. Okay. And I can put these slides up if you're interested in that. But the BJT analysis is probably more to the point, and I've worked that out now. I'll post that with when this video goes up. Okay. Gain boosting. Gain boosting is the... Oh, let me say one more thing about this circuit right here. This circuit right here has a special name. If you just string together all the adjectives to describe this, it's a cascoded, it's a differential input, differential output, cascoded differential pair. But that's really long, so what people call this is a telescopic op-amp. And the reason is that it's so long. It's spread out top. It's just the longest it could possibly.